Welcome back, everyone. Today we are going to talk about the relationships between arcs, chords, and diameters. So we've already learned about arcs and chords and how they relate to one another. Today we're going to talk about how those also relate to diameters. You should know these theorems. If a diameter or a radius of a circle is perpendicular to a chord, as shown here, then it must bisect the chord and its arc. So for example, if you're given that segment AB is perpendicular to segment XY, you can conclude that AB bisects XY, meaning that these two segments will be congruent, and it also bisects arc XY, meaning that these two arcs are congruent. You can also know that the perpendicular bisector of a chord is the diameter or a radius of the circle. So if you're given that segment AB is a perpendicular bisector of segment XY, you can conclude that AB is a diameter. Let's use this in a practice problem. It says in circle S, the measure of arc PQR is 98. Find the measure of arc PQ. Now, I see that QS is a radius of the circle perpendicular to a chord, so I can conclude that it bisects the chord and its arc. So I know that PQ, the measure of arc PQ, has to be half of the measure of arc PR, since it's split in half. So I know it's half of 98, which gives me 49. Go ahead and try the practice problem below. Here's the correct answer. Let's try another. This one's a little more complex. It says in circle R, find the length of segment TV. Round to the nearest hundredth. Now, what you need to know on this is you need to remember that every radius is the same length. I see that the length of the radius here in total would be 11. So I could draw a triangle here to make a right triangle. And I know that this segment TR must be 11. You could also draw a segment RV, it would also have to be 11. Now, I'm looking at this triangle TRS. I know SR is 6 and I know TR is 11. I know I can solve for the missing side, the length of TS, with Pythagorean theorem. So I know TS squared plus 6 squared must equal 11 squared. I can find the length of TS by taking 11 squared minus 6 squared and finding the square root. 11 squared is 121, 6 squared is 36. When I subtract that, it gives me 85. So I know TS is the square root of 85. Now I'm not trying to find TS though, I'm trying to find TV. Now what's helpful here is that I see that I have a radius, RU, perpendicular to a chord, TV. Anytime a radius is perpendicular to a chord, I know it bisects it, so I know TS and SV are the same. So I know that TV would be 2 times TS. So 2 times the square root of 85, which gives me approximately 18.44 units. Now it's very important for you to remember that you can draw another radius on this circle somewhere. You could have done the same thing with triangle RSV. You know the length of RV is 11. Use Pythagorean theorem to find the length of SV. Alright, another theorem for you says that in the same circle or in two congruent circles, two arcs are congruent if and only if they are equidistant from the center. So you can read this either direction. You can say, for example, if you know that segment FG and JH, which are two chords on this circle, are congruent, then you can conclude that they have to be the same distance from the center of the circle. Now remember, when you're measuring distance, it has to be measured along a perpendicular. So I have to measure from point L to a point that would make it a segment perpendicular to FG. I can also go the other way around. If I know that these segments are measured perpendicular to the chords and these two segments XL and YL are the same, then I can conclude that these two chords, F, G, and J, H, must be congruent as well. Let's try this out in a practice problem. It says, in circle A, WX equals XY, which equals 22. Find AB. So since the chords segment WX and XY are congruent, these two here, we can conclude that they have to be the same distance from point A. So we see that these are measured along a perpendicular. BA is perpendicular to chord WX. AC is perpendicular to chord XY. So I know that AB has to be congruent to AC. That means they have the same measures. AB equals AC. So now I can write an equation 5x equals 3x plus 4 and solve it. You get 2x equals 4, so that means x must equal 2. Now they asked us to find AB, so we'll have to plug it back in. AB is equal to 5 times x, or 5 times 2, which equals 10. You could double check your answer by plugging the x value back into the other equation for the expression for AC as well. You should also get 10. Alright, try the practice problem listed below. Here's the correct answer. And finally, I want you to reflect on this question. It says, if the measure of an arc in a circle is tripled, will the chord of the new arc be 3 times as long as the chord of the original arc? Explain your reasoning in 2 to 3 complete sentences. That's all I have for you today. Tomorrow, we will be learning about the measures of intercepted arcs when we have inscribed angles. So those look like this. We will be learning about that in our next lesson. I'll talk to you then. Bye.